Get me a Pythagorean theorem, stat. I need 10 cc's log 2x. Hello, mathematic. What? You divided by 0? I'm on my way. Welcome. It is Wednesday, August 19th, and this is the mathematic episode, Math Excel, Finding Domains, Kick It Up a Notch. Need help? This video's for you. All right, our first question is asking, identify the solution set for the quadratic inequality. Now you can do it by looking at a graph. This question is asking you, where is the graph greater than or equal to 0? Well, a graph is greater than or equal to 0 if it's above the x-axis. So this portion of the graph is above the x-axis, and so is this portion. So you want to describe the x-intervals where that graph that has these two pieces of the graph in it. Now the graph is equal to 0 right at these x-intercepts. Okay, so all of the x values to the right of this, the graph is going to be positive, and all of the x values to the left of this, the graph is going to be positive. So my solution set would be from infinity, negative infinity, up to and including 2. So I use a square bracket. Then I'm gonna combine that with the right hand side, which is from 4 up to infinity, and 4 is included. Now recently we've gotten a lot of calls into the Mathematics Central about what this symbol is. Okay, that symbol stands for the word union, which also is the same as the English word or. So union is just means you can pick a number from this interval, or you can pick a number from this interval. That's what that symbol means. The other symbol looks like this, and that stands for the word intersection. There's no need to use that symbol on any of these problems. Okay, so just to be clear here, if I had a set of numbers, let's say 1, 2, 3 was one set, and I had another set of numbers 3, 4, 5, and this was set A and this was set B. Okay, if I said A or B, what that means is give me all the numbers that are either in A, which are 1, 2, and 3, or are in B, 3, 4, and 5. I only have to list 3 once. If I asked you what's the intersection of A and B, then that's going to be the value that is in both. So that's when we use intersection, but that doesn't have any application with what we're doing right now. So that's what these symbols stand for. Now, the only difference on this one is it doesn't have an equal sign. So we're looking for, where's this graph positive? Well, it's positive wherever it's above the x-axis. So the graph is above the x-axis all through there. So the interval that defines those pieces, or that section, runs from -4 up to 2. Now this doesn't have an equals on it, so I'm going to write parenthesis -4 and 2. And that's any number between those two, the graph is going to be greater than 0. All right, number 3 is asking you to find the domain of that rational expression. The only time you have to worry about the domain is when you have one of these 3 situations over here on the wanted poster. All right, in this case, we've got a rational function And in the denominator, it's got variables. So to get the domain, I'm going to set the denominator not equal to 0. So I want to know, where is x plus 7, x minus 4 not equal to 0? Well, I take each one of these just like I was solving it for 0. So I know x is not allowed to be negative 7. Okay? If I solve the other one, x is not allowed to be 4. Okay? Now, what happens is, if I plug either one of these into this equation, bad things are going to happen, and the mathematic may not be able to help you. So we don't allow them to be used. All right, I'm going to show you why these would cause a problem here. Up here in the upper left-hand corner, I have a calculator. I took 4 and I plugged it into this equation. All right, and that's written right here. 8 times 4 minus 3 divided by, and then I went 4 plus 7 times 4 minus 4. Warning, do not do this at home. I'm going to hit enter. And I get error, cannot divide by 0. That is a fatal error. There's nothing I can do. I can't bring that equation back to life. So you cannot divide, you cannot have a 0 in the denominator. The x value might be 0, but once you do the math, if the denominator turns out to be 0, sayonara. So to prevent that, we exclude those from the domain. Now the way that we write this, how would I write all numbers except these two? All right, well, an easy way is just to write it out, right? I could just say the domain is going to be all real numbers except -7 and 4. And that would be pretty simple. If we're going to write it in interval notation, think of a number line. And I'm going to mark on it -7, +4. And I'm going to put a circle at -7 to show that it's out of bounds. Can't use it. Same with 4. All right, now if I plug in, or when I shade this, all the numbers that aren't -7 would be to the left, or they're smaller than -7. Any number in here is okay, and any number here to the right is okay. So I take each one of those intervals and I describe it. So this first interval on the left would be from -infinity to -7, not included. -7's fatal, can't include it. Or I can choose any number between -7 and 4, but not -7 or 4, because both of those, not good. Or 4 to infinity. Any of these groups, I can choose from any of these 3 buckets of numbers and operate that equation safely. All right, number 4, you're solving the same way. All you have to do is factor it first. So which two numbers multiply together to be 8 and add together to be -9? That would be -8, -1. So that denominator just becomes x minus 8, x minus 1, and it's a rational with a variable in the denominator. So I'm just going to set the denominator not equal to 0, and I'm going to solve it just like the previous problem. Okay, the next two problems are both solved the same way. Okay, you're going to factor them and then set them not equal to 0. So this is the difference of two squares. So hopefully in Algebra 2 you learned that when you had two perfect squares, they factor into a minus b, or a plus b, a minus b. The order doesn't matter. So this denominator simply becomes 3 minus x, 3 plus x. And then I set each one of those not equal to 0. So negative, I'm going to subtract x from both sides. So x can't be 3. And then the other one, x can't be negative 3. Those are fatal, poisonous. So if this was a toy laying around the house, you wouldn't leave 3's and negative 3's laying around that someone could accidentally plug into that equation and divide by 0. Okay, so now once you've got that, you're going to write it just like we did these previous ones. So it's solved the same way. Okay. All right. Number 6, again, solved the same way. All right, if we look at number 7 here, we got 1 over 12 minus 4x. All right, so in that case, I've got a radicand. I got a radical in the denominator of a fraction, a rational function. So I'm going to take that radicand, that's the expression, and I am going to set it greater than 0 and solve it. So I'm going to subtract 12 from both sides. I'm going to divide by negative 4. Now you got to remember, when you divide by a negative, you have to take the inequality and flip it. And then over here I would have 3. So now my answer is going to be all of the numbers that are smaller than, but not including, 3. So that's everything to the left of 3. And I would express that as negative infinity up to 3, but don't include it because that doesn't have an equals on it. All right, number 8 is probably one of the toughest patients to deal with because you've got a quadratic, it's a squared term, and it's under a radical. Okay, this takes some delicate techniques in order to solve correctly. So let's get started. All right, I know that in that particular case, that looks just like this. So I am going to set my radicand greater than or equal to 0. All right, so I've got 169 minus x squared is greater than or equal to 0. Now, if I was going to solve this, I would move 169 to the right, and I get negative x squared is greater than or equal to negative 169. Okay, then I divide by a negative number, negative 1, and that tells me I have got to reverse my inequality. So I want to come up with all the values of x that are less than or equal to 169. Now, in order to do that, okay, there's a couple of ways. We could graph 169 minus x squared and see where it's greater than 0. Okay, Or I could use the sign chart method. Okay, so since we're out here in the field, I'm going to use the sign chart method. So what I do is I'm going to factor 169. That's the difference of two squares. Okay, so that factors into 13 minus x, 13 plus x. That would give you 169 minus x squared. So the zeros of this, the poisonous numbers in this case, okay. Well, I'm sorry, I shouldn't have said that. Okay, sorry, zeros. It's okay for the number to be for this to be a 0 as a result, because you can take square roots of zeros. Zeros kind of got a bad rap. Okay. So I am going to take what makes each one of these zeros? Well, the first one is made 0 by the number 13, and the second one is made 0 by negative 13. Okay, so that divides my number line into 3 intervals. Okay, then what you do is you pick test numbers. So a test number is a number that's in that interval. Okay, so for example, a test number to the left of negative 13 could be like negative 14. Okay, so if I take negative 14 and I plug it into this first expression, I'm going to get 13 minus negative 14, which is a positive number. 13 plus negative 14 is a negative number. Well, a positive times a negative, this one would be negative, is going to be negative. So what that negative tells you, that tells you that this graph, 169 minus x squared, is less than 0 because it's negative. Okay, now we'll pick a number in this interval. So a test number, a good test number would be 0. So 13 minus 0 is positive. 13 plus 0 is positive. Okay, so in this neck of the woods, between those two numbers, my graph, or the value of this expression, is greater than 0. Now it's equal to 0 at these 2 points. Alright, so at that black dot there, 169 minus x squared equals 0. Right there and right there. And now my last test point would be something to the right, like 14. So 13 minus 14 is negative. 13 plus 14 is positive, and the result is negative. So that's just like this one here. So I am looking for, I want, where is it positive or equal to 0? Well, it's positive or equal to 0 in between these two. And I can include those two. Alright, so in interval notation, that would be bracket. Okay, people are asking me, what's the bracket? Bracket means the number is included. Okay, you're going to use that when you've got equal signs on your greater than symbols, or greater than, less than symbols. You're going to use parentheses if it's just plain old greater, less than. So this would be negative 13, 13. Case closed. All right. So you're going to do number 9 just like you did number 8. All right. Number 10, you're going to do it just like the other 9 and 8. All I would do first is I would factor it. what two numbers multiply together to be negative 10, add together to be negative 3, that would be negative 5, positive 2. Minus 5, plus 2. And then you're looking for where is that greater than or equal to 0. So you're going to solve it the same way as the other two. So I won't bore you with that. But you want to know where is it greater than or equal to 0. All right. Hopefully that helped. And good luck with that Math Excel. And remember, kids, don't divide by 0. This is Dr. Don, the Math Medic, signing off.